There are a couple more things we should talk about when considering linear functions and slope. A parallel line is a line that has the exact same slope. So if we have a linear function, let's say f of x equals 4x minus 3, then we can say h of x equal to, or no, sorry, let's start with g of x. G of x equal to 4x minus 2. This is a parallel line. That's because we care about the slope. The slope is the exact same, therefore they're parallel. Now, the y-intercept here has to be different for lines to be parallel. If we had something like h of x equals 4x minus 3, this is not a parallel line. It has the same slope, but it has the same y-intercept. In fact, this is the same line. Parallel lines never cross. They're parallel. They technically do cross at infinity. That's a different type of topic, but the lines never intersect, meaning there's no way you can have a point on both. However, if you have the same lines like f of x and h of x, they cross infinitely many times. It's very different than being parallel. Even though they have the same slope, they're not parallel. Okay, let's say we have k of x. This equals negative 4x plus 9. This is just not parallel. It's got a different slope, a different y-intercept. It's just a different line. So it really has no special relationship. But finally, L of x, let's say we have negative 1/4 x plus 5. This is not parallel, but it does have a special relationship. It is perpendicular. I can spell it correctly, perpendicular. And the reason why it's perpendicular, the book's definition is if you have two slopes. So in this case, f of x is 4, L of x has negative 1/4. 4 times negative 1/4, 4/1, those cancel, and we get negative 1. If you multiply the slopes and you get negative 1, they are perpendicular slopes. All that really is saying is that if you take one slope, you take the reciprocal of it, and then you give it a negative, that's how you get a perpendicular slope. It does not matter what the y-intercept is for both of these. They can be the same, they can be different. All that matters is the slope is negative reciprocals. So to recap, parallel lines have the same slope but different y-intercepts. Perpendicular lines only care about having negative reciprocal slope. The y-intercept can be the same or different, whatever that is. To kind of show you this graphically, if I have a line here, I could graph this line up here, 4x minus 3. Let me draw this a little bit better then. 4x minus 3, we go down to negative 3 first. Then 4x says we go up 4. 1, 2, 3, 4. Run 1. So that's 4x minus 3. And then, so that's going to be f of x. G of x is parallel, so 4x minus 2. That's going to be here. There. And you see the lines, if I drew them better, you'd see that they'd be exactly parallel. That is g of x. And then L of x, 1/4, negative 1/4 x plus 5. So going up to here. And then we have negative 1/4, meaning we go down 1 unit and run 5 units. So there's 2, 3, 4, 5. It's going to be here. Or no, sorry, it was negative 1/4, not 5 units. Down 1 unit, over 5 units. So we get this line here. And what you'll notice is this is L of x. What you'll notice is that f of x and L of x make a 90-degree angle. That's what a perpendicular line is. It's 90-degree angles. In fact, g of x is parallel to f of x and perpendicular to L of x as well. Of course, you can have any other line here that has different slopes. This has no special relationship. Just like this line doesn't either, or this line here. It's close to being parallel to the L of x, but it's not quite. Okay, here we have a couple problems. Give a line that goes through -2, -7, and is parallel to y equals -5x plus 4. So in the previous video, we talked about using slope-intercept formula and point-slope formula, and using the slope formula itself to find equations of a line. We're doing the same thing here. We need two things for a line, either the slope and a point, or the slope and the intercept. Here we have a point, and we have it is parallel to this line. Well, we need the slope, and if it's parallel to another line, that means it has the same slope as that line, meaning our slope for our line here is -5. This is the exact same slope. Okay, now that we have a point, so our name is x1, y1, and m, now we can use the point-slope formula to find the slope-intercept formula, which is the most important formula. Y minus y1 equals m times x minus x1. That's the point-slope formula. Solve for y, and we'll have the slope-intercept formula. Those cancel, and I'll distribute the -5. Give me y plus 7 equals -5x minus 10. Now I subtract 7. Y equals -5x minus 17. And that is a line that goes through this point and is parallel to this line. Okay. Here we give a line that goes through -4, 2 and is perpendicular to this line. Same idea. We have a point, x1, x2, or sorry, x1, y1, and is perpendicular, meaning we have negative reciprocal. If 1/3 is the slope of that one, the reciprocal is going to be 3/1, or in other words, 3. So 1/3 go to 3, and then the negative of that gives us -3. That's the negative reciprocal slope. You can always test it by saying -3 times 1/3 gives you -1. If you get -1, you know they are perpendicular. So our slope is -3. We have our point. We can use the point-slope formula. Y minus y1 equals m x minus x1. Those become positive, distribute the -3, giving us -3x minus 12. Add to y equals -3x minus 10. All right, last one. Give a perpendicular line to x equal to 4 and passes through -2, 6. So we have a point, right? This is x1, y1. Now we just need the slope. It's perpendicular to x equal to 4. Now x equal to 4 is a little weird because there's no slope, it's not written in the slope-intercept form or anything like that. But we know that x equal to 4 is 1, 2, 3, 4. It's this line right here. It's vertical. That means perpendicular to it is going to be a horizontal line. Because in any horizontal line is going to make a 90-degree angle on that. The question is, which horizontal line do we choose so that we have it passing through -2, 6? Well, let's actually plot -2, 6. 1, -2, 1, 2, 3, 4, 5, 6. That's the point right there, which means we want a line that crosses through the point and is perpendicular, in other words, flat-lined through, that's perpendicular to x equal to 4. Well, that's going to be y equal to something. That's the equation of a flat line. And whatever this y value is, that's what it is. It's the exact same y value as the point, which is 6. Y equal to 6 gives us that line there. You can tell they are perpendicular by thinking about saying that the y equal to 6 is the same thing as y equal to 0x plus 6. And 0, we can think of it as 0 over 1. And then the perpendicular slope, this is like having 1 over 0. Of course, negative reciprocal is when we make it doesn't quite work in this way because we're dealing with undefined slope and everything like that. But you see how they're flipped. 0 times negative is 0 still, so the negative kind of just goes away. It's a little confusing, but as long as you understand that vertical and horizontal lines are perpendicular to each other, then all you need to do is figure out which values do you want that satisfy your that passes through certain points. You can always graph these things to see if you actually have them correct. So one of the applications of linear functions, or in other words, the slope really of a line, is to find the average of some data, something like that. So we use data to make a graph, and it can be in like a scatter plot, which is just a bunch of dots on a graph, or a line plot, which the dots are connected with lines. And a lot of times we want to know what the average is. To do this, we can find the slope between 2 points on the graph, and that'll give us an average. So in this case here, for f of x, we're trying to figure out what is the average between x1 and x2. Well, to find the slope, we need to know what y is for these. The y value is the exact same thing as plugging in f into f, x1, and x2. So doing that at f of x1, right, we just plug 3 into this one and this one. 3 squared is 9. Negative 2 times 3 is negative 6. 9 minus 6 is 3. F of x2 is going to be negative 6 squared minus 2 times 6. 6 squared is 36. Negative 2 times 6 is negative 12. And 36 minus 12 is 24. Now, to find the average, so we can say, there's a lot of different ways you can say this. We could say x bar. That's typically one way to say the average. We'll just say that. It's really just the slope, or m, in other words, is right, y2 minus y1 over x2 minus x1. Y is the same thing, right? We can say y equals f of x. The same thing as saying f of x2 minus f of x1 over x2 minus x1. So f of x2 is 24, f of x1 is 3, x2 is 6, and x1 is 3. We have 21 over 3, which is 7. So the average between these 2 points of this function here is 7. It's a little bit different of a use of slope, but slope comes up in a variety of ways. I mean, especially if you take calculus classes, slope is very important for that. Okay, so this is going to be the same procedure. G of x1 is the square root of 9. The square root of 9 is 3. G of x2, the square root of 16, which is 4. So the average, or in other words, the slope, is going to be g of x2 minus g of x1 over x2 minus x1. We get 4 minus 3 over 16 minus 9, which is 1 over 7. So in this case, the average is 1/7.